Question 11 is an application problem for Unit 2, Rates of Change. Determine the value of a and b so that the function f of x equals to x squared plus ax plus b has a minimum at minus 4. Minus 11 is the minimum value and x value is minus 4. Okay, so here we have two variables, and to solve for two variables we should always have two equations. So one equation you can get straight away from the point, since the point is on the curve. So we can write that part. So f of minus 4 is equals to, we'll put minus 4 here and calculate. Minus 4 square is 16, and a times minus 4 becomes minus 4a plus b, right? And f of minus 4 is minus 11. So we get minus 11 equals to 16 minus 4a plus b, and we can take these terms on that side and find what b is, right? So it is, when I take here, it becomes 4a, and minus 11 minus 16 will be minus 27 equals to b. Is that okay? So we have this equation. Let's call this as equation number 1 for us. Second is that we have minimum at minus 4. So let's try to find where the minimum of this function should have been. So we can do difference quotient method. So we can say, well, at minimum, the instantaneous rate of change should be 0, right? So we'll use that policy to find out the x value for minimum. So instantaneous rate of change will be f of x plus h minus f of x over h, right? So for this, x plus h is x plus h whole square plus a times x plus h plus b, right? This is f of x plus h minus f of x, which is x squared plus ax plus b, right? Everything divided by h. Now let's simplify it. So when you expand this part, you get x squared plus 2xh plus h squared, this open this, ax plus ah plus b, and I'm writing these terms as minus of x squared minus ax minus b, right? And divide by 1 over h. Let me write like this, okay? That's the same thing, right? Now here I can write 1 over h, and here we have, you see, x squared and x squared cancels out, minus ax goes with this and b with this, correct? So we are left with few terms, and all of them you'll find have h in them, right? So h could be taken as common, right? Let me first write this as 2xh plus h squared plus ah, right? Now I could take h common and then cancel them, right? So you get h over h and 2x plus h plus a, right? Now this is what you get. Now since you can cancel this out, we can write this as, now since h is very, very small, we say h is very, very small, say 0.001, much lesser than 1, so we can neglect it, and therefore we get this equals to 2x plus a. So that is our instantaneous rate of change. For minimum to happen, this instantaneous rate of change should be 0, right? And since minimum is at minus 4, so at minus 4, the instantaneous rate of change should be 0. So we say 0 equals to 2 times minus 4 plus a, correct? So from here we can find what a is. 2 times minus 4 is minus 8, right, which comes on this side, so a equals to 8. Perfect. Now we will use equation number 1 and equation, let's call this equation 2, right? Equation number 1 is 4a minus 27 equals to b, and here we have a equals to 8. So I'll substitute 8 here and say, well, 4 times 8 minus 27 is equals to B, right? 4 times 8 is 32 minus 27 equals to B. And therefore 32 minus 27 is 5. Therefore we have A equals to 8 and B equals to 5. Correct? So I hope you understand what we did here. We had to find two variables, A and B, and therefore we needed two equations. First equation we got from the point itself. Since the point is on the function, we found f of minus 4, which is minus 11, and plugged in 4 here. We got a relation between A and B as equation 1. And then we did difference quotient method to find the instantaneous rate of change for this function at any point. And that happened to be at 2x plus A. And since we know that the minimum occurs at x equals to minus 4 and instantaneous rate of change should be 0 at that point, we equated 0 to this value. 0 equals to 2x plus A. Since x value is given to us as minus 4, we substituted minus 4 here and calculated A. So A was equals to 8. Now, substituting A as 8 in this equation, we got B. That's how we found both our variables A and B. Okay? I hope you have understand the method and you appreciate the way we went about. Have a good look at it, try to understand, because these types of problems are kind of difficult in the test. Okay? Best of luck. Thank you.